Глаза и уши самолетов-истребителей, радары для
The
речного...
eyes and ears of fighter aircraft, radars for inland navigation, and broadband internet for remote areas. These and many other microwave electronics developments enable Micran, a Tomsk-based company, to compete with such giants as Alcatel-Lucent and Ericsson. And now the company is going to enter international markets. The head of Micran Microwave Electronics Department is demonstrating a radar suitable for both five-star cruise liners and small boats. The radiation power of this device is lower than that of a cell phone.
In fact, here you see a complete radar set, the outboard part and the part installed on deck.
Видит радар на 12
The
километров.
radar range is 12 kilometers and resolution is so high that even an ice fragment or log will not pass the ship unnoticed. Its interface is the same as modern smartphones. You can control the device with the touch of your finger. Western competitors with bulky devices are only attempting to reach those levels, they say in Micran. Formation of the Microwave Electronics Department in 1991 was the first step in the Micran history. The project was inspired by Victor Günther, the irreplaceable leader of the company.
Initially, we were 8, all employees of the R&D department at the university. Over the last 20 years, we've turned into a serious company with close to 1,000 employees.
Initially, the production of their own branded devices was out of the question. The team started lower. In early 90s, Micran made components for other manufacturers.
One of our first products was a low-noise amplifier. We made the best low-noise amplifiers in the world. Our major opportunities are all connected with the field we started in, microwave semiconductor electronics. This was our area of competency when we formed the company. From this foundation, we slowly started turning to more complicated areas and equipment.
Today, semiconductor microwave electronics is an integral part of everyday devices, such as mobile communication and satellite television. However, satellites turned to be almost fatal for the company. The first large project of Micran was a global satellite communication signal system. It was expected to gain high profit.
We'd been working hard on this project until 1994 and had already built a complete satellite on the ground. And then everything crashed. Our chief designer just left us, and we suddenly happened to lose 90% of our contracts.
The company lost a major order and consequently money. Luckily, the developments found their application in radio relay communication lines for telephony and TV transmission.
These technologies were in strong demand at the time, and luckily we recovered at the last minute by jumping on this bandwagon and then becoming leaders in the area. We were sitting with Micran's CEO, Viktor Yakovlevich Günther, in this very room, and we were trying to convince him that a man can do no more than he can. We advised him to focus on one single product line to ensure a breakthrough. I now admit for the first time, and to such a large audience, that I was wrong.
Micran products are based on gallium arsenide chips. The company started to produce them after creation of the radio relay communication lines. This material has better properties than silicon, which is conventionally used in microelectronics. That is why it is indispensable in highly sensitive and powerful sensors, telecommunication and military equipment. This is the most powerful Russian line for production of monolithic integrated circuit of gallium arsenide and nitride. The air here is many times cleaner than in surgical rooms, and the clothes of employees prevent accumulation of static electricity. One spark or collision with a dust particle and the high-cost material for expensive chips is ruined.
This production line is designed for gallium arsenide and gallium nitride wafers of 100mm diameter. This is the only line in Russia which is designed for such a large diameter of wafer. And we're planning to produce 150mm wafers in the future. That will be the largest diameter available on the market.
It is more difficult to make monolithic integrated circuits based on gallium arsenide than of silicon. This is the reason why the defect ratio is typically very high. But Micran specialists address this issue as well.
As far as we know, the Ministry of Defense today uses the following figures in their calculations. The average ratio of non-defective wafer output should be at least 2 or 3%. Our output today of non-defective wafers is 50%, and that's the average for our entire production.
It is more difficult to make monolithic integrated circuits based on gallium arsenide than of silicon, so the defect ratio is typically very high, but Micran specialists address this issue as well.
We hope that this project will help us to enter foreign markets, because the domestic market will become too small for such products. This product's initially strong demand is in the civil and telecommunications markets. That's why this is our focus for this product.
The current production capacity satisfies only the company's internal needs, but Micran is planning to build a big factory in Tomsk for the production of monolithic integrated circuits of gallium arsenide.
A new trend was born. We called it the active phased antenna array. All serious radio electronic radar location-based systems now rely on this technology.
Радары из активных фазированных антенн.
Radars on the basis of Micran active phased antenna array, or APAA for short, are used in Russian MiG-35 fighter jets. This device is enabled to detect and intercept targets at enormous distances. They're essential for the operation of ballistic missile defense systems and communication systems between satellites and modern ships.
At least 14 ships already use our devices. These people not only undertook to enter these markets, but they even dared to succeed in those very different business sectors. Each one is a huge opportunity in itself. Few companies dare to enter such diversified markets because of difficulty and expense, and last but not least, each market needs you to stay constantly ahead of your competitors.
Another Micran department is responsible for designing and manufacturing of measurement equipment. It is required for the production and testing of microwave electronics. The company established a measurement equipment department to serve its own needs. None of the needed devices existed in Russia, and foreign ones turned out to be an unaffordable luxury.
It's fair to say that any of these devices cost $50,000 to $60,000 today, and we required a great many of those.
The initial goal was simply to provide the company with the needed devices. Implementation was entrusted to two young specialists. The unit had to support the major business. Such departments are called infrastructure departments. Infrastructure department is a service supporting corporate processes and not creating added value. The simplest examples of infrastructure units are accounting and legal departments. No major company can work without them, and there have been many cases when products of internal corporate services turned out to be useful outside the company. This is the way that modern Internet came about.
Tim Berners-Lee worked in the infrastructure department at CERN, the World Nuclear Research Center, where the now widely known Large Hadron Collider is located. And Tim Berners-Lee decided to write a convenient protocol for communication via the Internet. In those days, the Internet was only used by scientists. He wrote a program, and those three letters are now known to everyone. www. As a shrewd person, he realized when he'd finished the program that it would be useful to many people. Consequently, he wrote it in such a way that it was useful not only to the infrastructure unit at the Institute, but could be used all over the world.
The same happened to Micran. The quality of the measurement devices turned out to be so high that other companies took notice. The original staff of the original infrastructure department has grown into an independent business unit.
We're building a school on the basis of the accomplishments of this business unit, which has already proved to be commercially successful. This school is needed for development of the country, the industry, and this area.
Micran products sell in the whole country, from Vladivostok to Kaliningrad. That is why each component is tested for heat and frost resistance.
Yakut, the communication service provider, came to us with this problem. The Western equipment they used did not resist frost and actually failed to communicate under these conditions. That's why they brought equipment from us, and it's already been operating effectively for 3 or 4 years.
Micran constantly finds new markets. This here is a mobile communication system that ensures continuous cooperation of the units of national security, defense and law enforcement agencies. 32-meter tower resists storms.
For example, where there's a conflict, the system is transported to the conflict zone and an area of wireless broadband access is established, allowing subscribers to connect. The system collects and retransmits data, either to a communications hub or an anchor point in Russia's integrated communication network.
Despite all the achievements, Micran is not going to stop there. The company is planning to construct simultaneously 3 new plants. One of them, in the center of Tomsk, will produce radio electronic equipment.
This plant will produce radio, telecommunication, measurement and radar array equipment, and its output will be much closer to a finished production.
The second plant is planned for the Tomsk Technology Development Area, Special Economic Zone SEZ. There, Micran, together with Nokia Siemens Network, will arrange the production of LTE base stations, which are for 4G networks.